This video provides an example of how the water table recharge tool can be applied to a physical setting. The water table recharge tool might be used to make a quick estimate of groundwater head and flow at any horizontal position in an unconfined, relatively homogeneous material on a low permeability base that is situated between constant heads with uniform recharge at the surface. It simplifies flow by assuming the recharge is instantaneously and evenly distributed vertically throughout the aquifer and flow is horizontal. Field settings are always more complex than analytical models, so the user simplifies the field setting to emulate the analytical conceptual model. For example, to simulate this isthmus of land between lakes, we use approximate average representative values. The length of the system is 24,000 meters. The elevation for indicating a high water table will be 230 meters above sea level. The lake elevation on one side is 180 meters. The lake elevation on the other side is 170 meters. The net recharge is 200 millimeters per year. The aquifer base is 25 meters above sea level, and its hydraulic conductivity is 30 meters per day. By slicing through the earth, we can view the cross-section that fits the conceptual model. The distance x is measured from the left boundary. The aquifer base must be used as the datum to obtain accurate results because the water level elevation determines the thickness of the aquifer and thus its transmissivity. So we define an average value for the aquifer bottom of 25 meters above mean sea level. The aquifer bottom elevation is subtracted from the elevation of the lakes to determine the value that will be put into the equations to obtain the solution. The values can be substituted by hand and solved using a pencil, a calculator, or a spreadsheet, or the water table recharge tool can be used. To use the tool, click the green Run WTR button and enter data. I enter 24,000 meters for the length, 205 meters for the elevation, 155 meters for the head on the left, 145 meters for the head on the right, 30 meters per day for hydraulic conductivity, 200 millimeters per year for net recharge, 4 significant figures for the results, and 1 so that the results will be in decimal format. Then press Submit. Results appear below the input menu. First, the net recharge is shown and converted to consistent units of meters per day. This is precipitation minus runoff minus evapotranspiration. Below that, the flow rate to or from the left, the top, and the right are shown in cubic meters per day per meter into the image. The arrows provide a quick sense of the flow pattern. Next, the position of the groundwater divide and the head at that location are displayed. Finally, graphs of the head and flow as a function of distance are provided. On a computer, hovering the cursor over the line of the graph indicates the y value at each x value. On a mobile device, lightly touching the curve provides the y value, while dragging your finger on the graph shifts and resizes it. If the adjusted view is not useful, you can return to the original view by pushing Submit again. Given that this is a one-dimensional, steady-state solution, the recharge is instantaneously spread vertically through the aquifer and flow is horizontal, so the water table elevation represents the head at every depth. The menu items How to Use and Learning Exercise illustrate notable aspects of the WTR output, including response to unreasonable inputs, and results that are useful to have in mind when tackling numerical modeling in the future. I recall experimenting with this model in college and at first being surprised by some of the results, only to realize that they made sense mathematically and that common sense was needed for applying the results. I encourage you to use the tool to explore what-if questions of your own.